Welcome to today's edition of Scientific Exchange, brought to you by Medtronic's Cardiac Ablation Solutions Division. My name is Rob Carroll. I'm Chief Medical Officer of the various arrhythmia-associated divisions at Medtronic. And tonight we're going to have a special topic on the temperature-controlled ablation with our recently released DiamondTemp Ablation System catheter. And so we're going to have two talks tonight. First, on the history of RF and the biophysics of temperature-controlled ablation to kind of set a framework. And then we're going to have a second talk on the clinical experience with DiamondTemp. And then followed by a panel discussion with our faculty, where we'll be entertaining questions from anyone from the audience. And so if you want to submit a question as the talk proceeds, please do so in the Ask a Question section of the of your browser window. And we'll be monitoring those, and I'll try to incorporate as many as we can. We have a great faculty tonight. We have two speakers. The first is Luigi DiBiase, who's Section Head of Electrophysiology and Director of Arrhythmia Services at Albert Einstein College of Medicine in New York, and Amin Al-Ahmad, who's a cardiac electrophysiologist with the Texas Cardiac Arrhythmia Institute in Austin. Both are, as you all know, are just extremely accomplished ablators, and they have a ton of experience with the DiamondTemp catheter. So without further ado, let me turn it over to you, Luigi. Welcome, both of you, and Luigi, you have the floor.
Thank you very much, Rob. Thank you, Medtronic. Thank you for all the people connected. Thank you, Amin, for sharing with me this webinar. It's my pleasure to be here. And the task that I've been assigned is to kind of go through the history of radiofrequency. This is my disclosure, always important to be shown. So my agenda in these 10 minutes will be to go through the biophysics of RF ablation, talking about the evolution of RF ablation, the temperature control, the addition of irrigation, the advent of contact force sensing technology, high power short duration, and finally, some tips and tricks on the diamond temperature technology overview. And I'm sure that each of you have evolved the way they perform ablation in your own institution. But we never have to forget that radio frequency, it's a high frequency electrical current that is passed through a myocardial tissue between the catheter tip and a dispersive electrode on the body surface. And when we do this, we have to put together power, time, temperature, contact force, impedance drop. These are the information that we use or that we try to use to maximize our lesion formation. I would like to remind all of you that our goal is to have a transmural lesion, and all the information that we use help us to achieve that endpoint. So the lesion formation is very important because it's not only a combination of conductive heating, but also resistive heating, as you can see here in the graph. So the lesion formation with the RF ablation has, a temperature increase that is due to resistive heating and conductive heating, but also is affected by the degree of the tissue temperature, by the tissue temperature beyond 50 degrees, and by a tissue temperature that is beyond 100 degrees. And we all know that there are differences if you are above or below this marker. So we evolved the way we perform these lesions. We started with non-irrigated catheter that had some challenges. The lesion creation was guided by direct temperature feedback. There were some safety challenges, including steam pop, and this was impacting the outcome, of course. Then we moved to irrigated catheters with a cooled ablation catheter tip that had to enhance the safety and efficacy of our ablation, but introduced challenges around the EGM signal interpretation and reliable temperature assessment. Then we try to improve by adding contact force. They were developed to provide an indicator of lesion quality in the absence of reliable temperature measurements, and resulted in perceived safety benefit due to improvement in formation of tissue contact. Then we almost all evolved to high power show duration. I have to say, I learned from my mentor to use this since 2006-7, but it's something that now everybody uses. And the EP recognized the benefit of altering the resistive and conductive heating phases to enhance lesion geometry, but recognized the need for direct temperature feedback. And finally, we have this new catheter acquired by Medtronic, which is the temperature diamond tip catheter, which give us an accurate temperature sensitive enabled by isolated thermocouples that allow an open irrigated catheter to run in temperature control mode. We will have time to discern this catheter in more details. Going back to my agenda, in 1990, Dr. Haynes and Werov were looking at the biophysics of this, and they already concluded that the lesion size was directly proportional to the peak temperature for all ablations, but not to peak power, current, or voltage. And maintaining an electrode tissue interface temperature less than 100 degrees was able to avoid complication associated with a sudden rise in the impedance. And you can see here how this is well displayed in this graph here, where the lesion width versus peak electrode tissue interface temperature for all the vitro square and in vivo circle lesions. Ablation during which an impedance rise was observed are represented by solid symbol. And you can see here the correlation. Then, we have a background. Dr. Colkins, in an old paper in 1994, look at, the closed loop temperature control for RF ablation. They look at the possible coagulum that was forming at that time. And so the conclusion was that temperature monitoring with closed loop control of power output facilitates RF catheter ablation procedures by minimizing the probability of developing a coagulum while ensuring maximum lesion formation. At that time, uninterrupted anticoagulation was not available, and that's also an important information to be taken into consideration. Then, in 1995, Nakagawa started looking at the effect of open irrigation to the tip electrode or RF catheter in, of course, in vitro porcine muscle preparation. 3 different setups were used: power control, temperature control, and power control with the external irrigation of the tip electrodes. And I would say 2 major findings were there. The first one was that external irrigation allowed for a maximum power to be delivered through the whole ablation duration, resulting in better lesion, almost twice as big than temperature control and 3 times bigger than power control with no irrigation. Second information was that the temperature measured by the external irrigated tip electrode does not reflect actual tissue temperature. And this is well displayed here. You can see the RF lesion dimension here of constant voltage, temperature control, and constant voltage with irrigation. You can see graphically this. Finally, another thing was added, which was, but I need to know what is the feedback. I need to know what's my force that I'm applying. And so contact force technology was added to our portfolio. And Yokohama and many more did many contact force study, different technology, but for sure, for a given power and for a given ablation duration, lesion size significantly increase with contact force. And you can see these 30 watts, 50 watts, 30 watts, 50 watts here, maximum lesion diameter and lesion depth. I think that the following slides is more intuitive for everybody you can see 2-gram lesions at the 40 watts, same lesion duration. When you move to 10 grams, 20 grams, 30 grams, 40 grams, you can clearly see a difference in the lesion depth in this animal. So contact force try to be there, but we still power contact force. All these are surrogate of information because we have no catheter that could reliably give us tissue temperature. And I would like to show you later a slide where remember how the best chef that you like and the best restaurant where you like to go, what they do when they want to do your steak or your fish well done. They put a sticker in the meat or the fish to measure the temperature into the tissue. That's the best way to assess the lesion formation. And this is something that we were missing. In order to overcome the way of measuring the tissue temperature, high power short duration has been now probably used by many of us. And what it does, it change the balance and the scale of the resistive and conductive heating from this to this. So basically, we rely much more on the conducting heating by starting the lesion at a higher power and staying the same spot for a shorter period of time. This way of performing the ablation has improved a lot of lesion formation. In fact, the high power short duration altered the relationship between resistive and conductive heating, as I already said, and result in superficial tissue injury by resistive heating without time-dependent conductive heating. Can lead to the following improvements: wider surface lesions, better contiguity in PBI lesion set, and less lesion depth. Potential drawbacks: fixing power and time may not account for a varying tissue thickness, catheter stability, and cardiac motion, may be a narrower safety window without temperature control. And here, many more parameters will be included because are you doing this with the deflectable sheet, non-deflectable sheet? Are you doing this for 30 seconds, for 15 seconds, from 10 seconds? So a lot of information are necessary here to detect your best high power short duration. But again, what we're missing is the reliable temperature tissue measurements. And that's what the DiamondTemp ablation system tried to do. In fact, as you can see here, this catheter has the capability of measuring in a reliable way the tissue temperature. And the software is able to titrate your power based on the temperature that is in the tissue. And this time, the tissue temperature is not a surrogate, is not something that the thermistor give you, but it's very reliable. So you can see here the tissue temperature is an indicator of lesion formation. You can see very well here how the higher temperature correlate with a better lesion formation. The diamond network enables low flow irrigation and an accurate temperature sensing and clear AGM, and the split tip electrodes allow for a high resolution EGM recording. You can see here at the ablation distal how this is much better when you start, and you can see the disappearing of the electrograms when you are burning. So now I feel that this catheter has given us the missed piece of information of the puzzle that we need to improve our lesion formation. And before giving the presentation to Amin, again, remember what your chef does when you want to cook your chicken, when you want to cook your steak, when you want to cook your fish. If you are vegetarian, you have to know what the tissue temperature is when you want a well done cooking. And I would like to thank all of you for listening to my presentation. Thank you very much.
Hey, thanks, Luigi. That's great. I prefer to keep my steaks around 135 and not 165, but that's my own personal preference. Look, great presentation and set a great background, and you nicely outlined kind of the importance of getting back to tissue temperature so you don't have a surrogate. But, and you talked about how that can translate with the DiamondTemp into efficacy. How do you view this from the standpoint of safety? Where do you think the advantages are with DiamondTemp from a safety standpoint?
I mean, Rob, thank you for this question. This is very important. I think why we are talking about this, because for many years we had reconnections, and we see reconnection. We ablate the veins, we go inside, and we have reconnection with any energy source, with radio frequency, with cryo. And each of us have some reconnection. I can say I have less than you. You can say you have less than me. One operator says better than another, but we all have reconnection. So what does it mean? That our lesion formation is not optimal. So all this technology have evolved. Why? To improve the transmurality of the lesions. And why that? Because we can't cut the tissue that we are burning. We have to rely on all the information we have. The more we have, the better. So we have the electrogram disappearing, we have the impedance drop, high power show duration, we do high power, but all of this, when you do high power with a non-deflectable sheet, with an Agilis or any other big sheet, you also can perforate in order to achieve your goal, which is transmural lesion. So if I can have a software, a technology that can measure reliably the tissue temperature as the chef is doing, I think I'm confident that my lesion is transmural. I have an information, and the computer will reduce my power while my temperature in the tissue is high. So I think I can potentially reduce possible complication. I know technology has reduced the complication, but complications are still there. Now, many people will say, well, you don't have contact force. How can you avoid complication? Well, the software do not need contact force. Doing the ablation with power control is different than doing ablation with temperature control. If I have a temperature that is reliable, the power will be decreased. So this technology do not need contact force. This technology need me to be in contact. And I know when I'm in contact. I know when I'm in contact because I know the electrograms has a high voltage. So contact force will give me other advantage, has some potential information that I like to have, but is not essential for this technology to achieve a transmural lesion. And so I'm confident I can give a safe lesion, I'm not risking a perforation, and I'm giving a transmural lesion.
One other quick question that fits is, you showed data on tissue orientation. So thoughts on DiamondTemp's ability to measure temperature irrespective of various orientations?
Yes, probably this is a drawback of the catheter. Contact force, I think the best thing of contact force is to give you the vector and the orientation of where you're burning. With this catheter, you don't have that, but you have a reliable tissue temperature. I mean, these are all optional information that we have to achieve our goal. Yep. If I can get both together, which is the case today, because DiamondTemp has one and doesn't have the other, and contact force catheters have the other and don't have tissue temperature. So we have to pick, each of us have to choose what is best for your practice. Overall, the goal is transmural lesion. And if I have a way to know that I'm giving to my patient transmural lesion, I'm satisfied.
Yeah, and I will add that DiamondTemp does have 6 thermocouples, 3 at the tip and 3 at the back end of the ablation electrode as well. And I think Amin will talk about that.
Yeah, so, I'm sure Amin will focus on that. So, yeah, we'll discuss later.
So let's turn over to Amin Al-Ahmad to talk more about the clinical data around the DiamondTemp catheter.
Great, Rob, thank you very much. Thank you, Medtronic, and thank you to Luigi for setting things up and giving a terrific talk. Let's see here. Okay, so I'm tasked with talking about the clinical experience with the DiamondTemp ablation system, and I've been pretty fortunate to use this catheter quite a bit now within the clinical study. So I feel like I can talk a little bit about my experience with it, but also a little bit about the clinical study experience. These are my disclosures. So in terms of the clinical study, I think there's a couple of things that are worth noting. And this paper was published recently. This is data from the paroxysmal AFib study. It was an FDA study, 482 paroxysmal patients randomized. These were randomized patients to the DiamondTemp catheter versus a contact force catheter, which was the Abbott system catheter. So it's randomized against contact force, and we basically were part of the study and used the catheter within the context of the study. Now, a couple of important things I want to point out. So first of all, primary safety endpoint. So here, 3.3% safety events compared to 6.6 with contact force. And I want to point that out only because there's this fallacy of thinking that contact force is safe because you have contact force. And I can tell you, I've been doing a lot of ablation, and contact force has never really decreased our level of complications at all. But one of the interesting things we observed with this catheter is that we never popped. We didn't have pops with this catheter, which is kind of interesting, thinking about the amount of power that it's putting out and the temperature we're achieving. Now, freedom from AFib is on par with contact force. And you can see here in terms of the Kaplan-Meier curves that they're identical. So this is comparing to contact force. But you dig in a little deeper and you see a couple of very interesting things. You see that RF time with DiamondTemp is actually shorter than RF time with control. So you can achieve the same endpoint, but less ablation time, perhaps meaning that the ablation was a little bit more effective once you achieve contact, which is what we saw anecdotally, which was what I saw when I did these procedures. The other thing that's worth noting is that the saline infusion volume was a little bit lower, or actually substantially lower with DiamondTemp. So keeping that in mind, I think we can talk about the data and what people have done, but I'd like to kind of show you guys a case and see and maybe get some comments and see what everybody thinks. Just to set up the case, this is kind of how we do our procedures. We do these with uninterrupted OAC. We use access with ultrasound. I typically do 2 transeptal sheaths, one an SLO for the ablator and a LAMP 90 for the circular mapping catheter. We always do 2. I never use an Agilis or a steerable sheath. Always put in an ICE catheter, and then always put in an 20-pole catheter from the internal jugular. I think Luigi does the same, mostly for stability, catheter stability, if you want to map a flutter, and then also in case catheter's not banging too much when you're on isopril. The only thing different now, when we talk about ablation approach, usually if I do ablation approach, I'll tell you what my contact force usually is. I don't have to tell you that now. I just tell you what my target temperature is set at. So I set my target temperature to 60 degrees. And then I do things essentially the same as I would with any other catheter. It's exactly the same. The only difference is I set my target temperature to 60 degrees. So I do drag lesions. That's kind of how I've always ablated. And the goal is to eliminate electrograms that I see on the tip of the catheter, and I'll talk a little bit about that, and also on the circular mapping catheter. Typically, we'll go for the pulmonary veins, posterior wall, and then look for other triggers or if there's flutters or things like that. A couple of things to point out here. Just probably what I really want to point out here is the tip of the catheter. You can sort of see where my arrow is, that number 7. That's this sort of split tip electrode. And what that does is that gives you a very, very sharp, clean electrogram. And it's really quite good because when you're ablating, you can actually see the electrogram diminish. In other words, the noise from the ablation does not take away your ability to see that. And that's actually very helpful when you're doing these ablations. The RF generator on this measures, again, there's 6 thermocouples, but it measures every 20 milliseconds. So it's measuring very rapidly, and it modulates power in real time. You'll see the power go up and power go down, and that's what we actually look at when we're doing these ablations. So this is the case, and just to kind of set it up a little bit, here's my ICE screen. You can see that. That's my 3D electroanatomical mapping screen. And then here overlaid on the anesthesia screen is the DiamondTemp control screen. And so you can see we've set 60 degrees. It'll tell you what temperature we're actually achieving, what our power is, what the impedance is, and you can see the graphs and you can see how the impedance changes. Here's my fluoroscopy screen, and here's my real-time screen and my other screen. And so just to tell everybody, we're going to start the video, but basically, I do use fluoroscopy. I know that there are folks that don't use it. I generally get about 5 to 15 minutes, depending upon the case. Now look here we're ablating kind of anterior on the ridge. That was the initial spot. And it stayed on the ridge pretty well. So that's kind of the thing that I really liked about the catheter is you have pretty good control.
So, sorry to interrupt. For people that are not familiar with the DiamondTemp screen, so you're burning here. Can you show what is the temperature that you have and how the power change according to the tissue temperature?
So as I mentioned earlier, you can kind of see this screen up here where my arrow is. And you can kind of see there it's 45 degrees. I get better temperature. It gets into the 50s. There I'm on the ridge, hits 60 degrees. There's the power. So you can kind of see how much power. There's it looks like duration, and there's my impedance change right there. And so you can kind of see, again, hitting 55 degrees, 61 degrees. There's my power changing. A couple of things that are interesting about this is that it actually kind of validates to some extent high power and short duration, if you will, because to achieve good tissue temperature, you do need to get up to 50 watts, which is interesting. And when I saw that, I was very intrigued by that. But what you're able to see pretty clearly is that the impedance will drop with these, and the power will go up. Now, one thing to notice is that occasionally the temperature may not always be at 50, and that may just be that you have to adjust your contact a little bit. And again, the issue is just a small tweak in the catheter. And again, the catheter moves micro motions very well. You can achieve better contact, and the temperature goes up to the 50 degree plus range, and that's when you're getting a good ablation lesion right there.
And again, you're using this 50 watts, considering that you have non-deflectable sheet, as you mentioned before. And I agree with you that it's kind of, I'm seeing this vein being delayed, and you're going to isolate very soon. So I agree with you that high power short duration, what we do, we try to increase the power because we want to have a transmural lesion, but we don't know if we are exposing ourselves to a possible complication. You need to move quickly. So with this one, once you have contact, you don't care about the force, the power will change automatically according to the temperature. So it's very important you explain a little bit this more.
Just a couple, again, we set the temperature, the target temperature, and it'll achieve that temperature for us with varying power. So whatever the power is, it is what it is. You can kind of see the graph here also on the bottom next to my live screen. You can kind of see the temperature that I'm achieving. You can see the amount of power that's being delivered. And so it's actually pretty easy to understand where I am in terms of contact. So I hit 60 degrees, my power drops from 50 a little bit, it keeps going up. And part of that's because I'm moving the catheter. But I did want to mention also that it's pretty easy to move. Again, you'll see I'm tooling around this left atrium pretty easily without a steerable catheter, so without a steerable sheath. So that's one of the things I think they got right. I think that oftentimes when companies come up with a new catheter design, they care a lot about the tip technology, but nobody talks about the handling or the shaft technology. And I think it's just as important. I think when you handle a catheter, you have to understand how it responds to torque and everything. And this one, I was kind of pleasantly surprised. I was actually expecting it not to function well because it's a new catheter on the market. But boy, it just, and you can see that's not just me saying that. If you look at the clinical study, you had equivalency in terms of success rate, you had less ablation time, and you had lower complications. So all in all.
Do you use a unidirectional catheter I'm seeing here?
Yeah, I'm a little bit old school from that perspective. I know some people like the bidirectional, some people like the steerable sheath, some people like steerable sheath and bidirectional. You can do whatever. I typically like the unidirectional. That for me tends to work the best. In this particular case, the patient actually came in AFib and actually did have a large atrium. You're right about that. And so we did end up using a little bit of a larger curve. That's kind of the final map. And again, you get the idea that you can kind of tool around just about everywhere without too much difficulty with this. A couple other things to show. Signal attenuation, pretty good. So this is what we're relying on when we look at this. So you'd see RF on, and then within a few seconds, it goes away. Same thing here. This is from an animal experiment, RF on, and then you can reduce the electrogram, and you can actually see it very, very crisply. And so that matters when you're doing these ablations. So here's a couple of key points. Catheter handles very, very well. It does very rapid ablation. It melts these signals away. It's really kind of fun to watch. It's actually easy to ablate in areas like the ridge. It's easy to ablate the CS, both endo and epicardially. It's easy to move it around. It has a lot of stability. Ablation endpoints for this, because of the way I do things, I don't remap with the mapping system. I look at the electrograms. They're very easy to see, both on the ablation catheter and then with the circular mapping catheter, kind of moving it around after the ablation, making sure that I've eliminated the electrograms. And that's good enough for me. Assessment of good contact, I use the mapping system to tell how close I am to the wall. Then I watch the temperature. If I'm not getting to that 50+ degrees, I just advance just a touch, very small motion, and I get my 50-degree plus temperature, and I know that I'm in good contact. If you're pushing too hard, which actually had not been a problem with us, you might get a high temperature and a decrease. It really tended not to happen very often. What about fluoroscopy time and contact force? No change in my typical fluoroscopy time. For me, I'm about 5 to 15 minutes, depending, again, more so on the posterior wall when I want to look at how far away I am from the esophagus. That really didn't change. There are people that I work with that do not use fluoroscopy at all, and they've been able to successfully incorporate this into their workflow without use of fluoroscopy. Catheter tends to handle very, very, very well. Like I mentioned, it's not just the tip, it's the shaft. Everything tends to handle very well, and if not better than some of the contact force catheters on the market. And then better signal on this catheter than contact force. The signal during ablation is very good. I really don't think you need a lot of these surrogates like ablation index or FTI with this. I think those are all surrogates of surrogates of surrogates, and you end up ablating a little more and end up potentially causing complications with some of these surrogates. So I'm not a huge fan of those. I really like the idea of temperature and like the idea of being able to do a quick ablation. And just a little plug, there's a persistent study now ongoing, and so we're also part of that study. So this is a global multi-center perspective IDE study. There'll be about 300 subjects enrolled, about 50% out of US, 50% within the US. Again, we're one of the sites, and similar kinds of questions will be asked as typical studies. And so I'm looking forward to that study conclusion and hopefully the data soon. Of course, everything got a little bit delayed with COVID, but it's up and running again, fortunately. With that, appreciate the time and happy to take questions.
Great, that was terrific, Amin. Couple questions. One was a question kind of I had, but also came in from the audience. And you mentioned specifically about the catheter handling, but can you comment about kind of the learning curve or the fact that, right, it's not just a new catheter, but it's a new way of looking at the ablation parameters and that package of information, the electrograms. How long did it take you to learn how to use this?
Yeah, I mean, if you're doing AFib ablation, then it doesn't take long because we're used to it, right? So I can tell you when I used to train fellows on AFib ablation, I would tell them you have to have eyes everywhere. You have to have an eye at the power, the temperature. Even with contact force, you had to have an eye on the temperature, an eye on the fluoro, an eye on the ice. And so with this, it's very similar. You have to keep your eyes kind of darting back and forth, but that's what we always do. And so the only difference now is I'm looking at the temperature instead of looking at the contact force. And so for me, it works really, really well. So it didn't take a whole lot of time to learn. And more importantly, I think the actual learning of manipulation of the catheter was minimal. I mean, it literally, you pick it up, you use it, it's easy to use. That was kind of refreshing and nice. It wasn't one of these catheters where you have to learn how to figure out your hands. That was not the case at all. So from a learning perspective, I thought it was very straightforward. You know, one case, you're done, you're ready.
So the other question came up as I was listening to the talk was like, you talked about setting the temperature and then ablating, letting it adjust. As you are kind of, doing your wide area, antral ablation, you're on the ridge, you go to the posterior side of that. Are you resetting the temperature adjustments or are you just ablating?
No, I'm just ablating. I mean, I think one of the things we've sort of learned how to do over time is adjust our time rather than adjust our temperature and wattage. And so you could, I mean, there's people that do that, right? They'll go low output or low watts or low temperature on the posterior wall and higher, on the ridge. But for us, it's a matter of adjusting time. So I spend less time posteriorly and I try not to, heat stack, if you will, where I don't do a lot of lesions all close to the esophagus. I'll move back to the anterior side again or back to another side where I know is safe. And so that's all it is. But yeah, I don't change any of those parameters.
Rob, I mean, I feel this is an important point that you touch. And I don't know, I think I requested another slide where we can see like the display of the diamond catheter. I think this is the new monitor. So, yeah. I mean, explain very well. The catheter, you want to have a unidirectional, you want to have a bidirectional, you have a small curve, a big curve. It replicates very well what we routinely use, and you take it in your hand. I feel like I know how to use this catheter. What is new is this display. And that's the only thing that is new. I don't know if, you want to go through it.
Yeah, I mean, pretty straightforward. You set, these are the settings. Temperature is set at 60. You can set your duration, whatever you want. I set my duration to 300 seconds, so it just keeps going. And then the flow rate, the nominal is 8, which is low, right? And so at least compared to Tacticath, pretty low. And so then duration, this is how long I've been ablating, the impedance, and you can see a percent change, which is kind of a little helpful graph here telling me if I've dropped the impedance, and then the amount of power that I'm pushing out and the temperature, what my temperature is. So I can use this to guide my ablation. But again, it really doesn't take a whole lot of wizardry to figure this out. It's easy, Luigi. I mean, you've done this, right? You just put the catheter there and you turn on ablation.
So I think this display very well. Like, there's really nothing much to learn. It's what you do every day. This power, if the temperature goes down, the power goes up, and vice versa. It's very intuitive. There's not much to do. You will see the signal melting there, and the catheter works very well.
Like I said, I know you don't have the arrow, but on the ridge, I showed you it's incredibly stable on the ridge. And the temperature recording, because it's recording all around the tip of the catheter, you're getting a decent temperature recording. So I'm getting 60 degrees on the ridge. I don't need to know the arrow because I already know that I'm in good contact because I'm achieving good temperature and achieving good impedance. And so it's really pretty straightforward.
I mean, we need to give take-home messages. And I feel like this technology, to work properly, do not need you to have force. You need to have contact. And, the tactile feeder of the operator, the high voltage signal of the catheter, you will know when you have contact. If you have contact, the technology will take care of the power of the lesion. So that's a take-home message that we need to give to people.
I think one of the things that was impressive to me, Luigi, was we were hitting 50 watts of power in areas where we were spending time and we were not popping. If you tried that with a standard contact force catheter, you may very well pop. Now, there's some people that do that all the time. They move around very, very rapidly with 50 watts, but they're moving every 2 seconds,
On the other hand, some people like to do the procedure with no fluoro. I saw you use fluoro. I use fluoro. I think using minimal fluoro has not much different than having no fluoro. Some people say, well, I don't want to wear the lead at all. And they say that the contact force when you do fluoroless procedure is extremely important. What's your take on that?
Yeah, I guess everybody develops their own way of doing that. And I can tell you that one of my colleagues, who was one of the first people around to do zero fluoro, will use non-contact force catheters all the time, and so I don't know that you necessarily, and he uses non-contact force catheters like Tacticath, not like flexibility, for example. So, I don't know that you absolutely need to have contact force if you're doing zero fluoro.
I agree with you, and my answer to that is we thank technology for all the information that they give us. One company come with contact force, another company come with tissue temperature. I mean, we have a variety of information that we can choose. We choose what we want. If you use one technology, you don't have tissue temperature. If you use tissue temperature, you don't have the other one. I think it's important to have a variety of information. Yeah. Then you have to decide what's best for you. If you have a lot of reconnection, probably, even if you have contact force, you're doing something wrong or you need a different technology. I think, the more the technology help us, the more information we have, the better it is for the outcome of our patient. And I think that this technology adds something to the field.
Yeah. Let me chime in with a couple other questions because I love this conversation. First off, do you guys do point lesions and stop or dragging? You kind of hinted that a little bit, Amin, but I'll let you answer first and then Luigi. And then to the second half of that question would be, when you switched to this catheter, did you have to change what you were doing?
Yeah, I really didn't change anything in what I did. Literally the only thing I changed is I just set a temperature instead of set anything else. So I do drag lesions. That was the same for me either way. I think if you do point by point, you can still use it. There's no reason why you wouldn't be able to. It didn't change any of my other workflow. And importantly, I didn't change my fluoro time. And you saw there was periods during my case where I didn't put my foot on the fluoro pedal, and I was doing zero for that period of time, fluoroscopy, which is kind of my standard. I didn't change much. So, Luigi, what about you?
Yeah, I mean, I think we learn from the same mentor. So we use drag lesion as well. So I drag and I constantly move my catheter. With this catheter, I'm even more confident that, sometimes people say, oh, you're burning at 45 watts, high power, short duration. And, you don't realize because we move quickly the catheter. So this one is even safer because I know if I'm staying too long in a specific location, if the tissue is going up, the technology will go down. So for dragging lesion, this is amazing. For point-by-point lesion, it's great as well. A lot of people work with me when I do cases, and I tried even to use this with point-by-point myself. It worked very well for either dragging or point-by-point. It's a matter of, the more you use, the more you get familiar with technology. So I feel that if you decide to use this catheter, it's intuitive, you can use it, and it gives you a lot of good information to achieve a transmural lesion. If you use a different catheter, you will have to use different surrogate of information to achieve the same endpoint. At the end, what counts here is to isolate the veins in a durable way.
So one other thing, and then after that, I've got one last question to close with. So, both of you mentioned the ability to see electrograms better with the split tip. So that's one, that electrogram diminution is important. What other parameters do you guys like to use to know when it's time to drag?
Yeah, for me, a couple of things. I do look at the impedance. I look at the temperature. I really look a lot at the electrograms, to be honest. And then the other thing is, it's almost like this internal clock in my head that tells me when I'm posterior, I'm dragging at this rate, and when I'm anterior, I'm dragging at that rate. And then obviously other structures like the esophagus play a role. If I'm close to that, I drag a little faster, or jump and then drag kind of thing. So. But yeah, it's pretty straightforward. The impedance drop is pretty obvious. The temperatures are pretty obvious. It's not that, I don't know, Luigi, what are your...
Yeah, I look at the signal elimination. For me is very important. So this catheter give me that. So that's one of the first things I look. The second one is the impedance drop. And the third one, of course, if you have the ability of doing 3D mapping system, the remap, if you see a change in the voltage, which is the same of the signal disappearance, or should be the same. That's the way to go. But a topic that we don't discuss is sometimes you start thinking about epicardial connection on the posterior wall, and people start talking, maybe you don't reach the vein of Marshall or other things. I mean, when we can achieve that, we don't know, I can burn at 50 watts with high power short duration, but I don't know if I cannot achieve the lesion because I don't know what's the real tissue temperature inside. So this technology will be able to fix that gap. Yeah. Now, is this technology enough? Or, technically, if you implement the vector and the force, even if you don't need the force, but having more information, of course, counts. But remember, I think the example for this technology is you're burning 50 watts and you cannot eliminate that signal. I think in that case, I wish I could have tissue temperature, because if I know it's not 60 degrees, that's why I'm not reaching the other location. And we talk about this epicardial connection all the time. I would like to really know with this catheter, when I cannot isolate something epicardial, is because the temperature is 60 or not. That would be a very nice, research idea.
Yeah. So one last question kind of around change management. So the question came in from the audience. All they've ever used is a contact force catheter. They know the system. And the question was essentially, what about this was the most eye-opening thing to make you change? Like, why should this person change? So let me start with Luigi, and then Amin, I'll go to you to close for the final thought here.
Well, when you have a workflow, it's always hard to change, and it's very hard to change for everybody. On the other hand, the limitation you have with your own workflow. So, and sometimes before you say, oh, I'm good with what I use, you have to experience something different. So I think you have to experience this catheter, use it, and then each operator will feel what is best for them. I think if you do some cases, you will not be disappointed by the learning curve of this catheter. This catheter will be an easy learning curve for everybody. Then after you use it, you will have the opportunity to decide if having a reliable temperature is more important than having other information. I feel that this catheter is easy to use, and the everyday use will determine what is the best workflow for yourself.
Amin?
Yeah, I think it's a little bit, for me, it was a little bit of a back to the future thing, right? So when I started doing ablation, we only had solid tip. And then, irrigated came out with like the Chile catheter. And I remember doing AFib with 8mm tip and looking at the micro bubbles. And then we did, the open irrigated with no contact force. And so all of those had something missing. And the biggest problem with all of those, period, was the lack of temperature, except for the early solid tip days, was lack of temperature. Absolutely no question about it. And then you sort of think about, well, now we've got contact force, we're perfect. We really aren't. It hasn't improved our safety at all. I mean, and I think that's a big problem that we still have. And so people come up with all these things. Well, let's use this algorithm and you achieve this number and it magically drops a lesion. And all of these are real surrogates. They don't tell you anything. So why did I like it? Why did I pick it up and like it? One, it handles extremely well, which for me matters because I don't want to sit there and struggle. It's a long day. I want to just get through my case. So it handles extremely well. Two, the electrograms are extremely crisp. And so you can actually see the electrogram dissolving, which is really nice. And then three, you get temperature. And so it's sort of what we always wanted, an open irrigated platform with temperature. And so I would say if you're thinking about it and trying to decide it, pick it up and try it, because ultimately you be the judge. Once you try this, I think you'll find that it's very easy to use. The safety profile is outstanding and you'll like it. I'm pretty much convinced most people who try this will like it.
Great. Look, with that, I want to thank you both for just an incredible discussion.